Okay, so we are doing now rate of convergence of Newton-Raphson method. Okay, so if fx is equal to 0 is our equation and x is equal to alpha is an exact root. So then we already know the formula of Newton-Raphson method. This is going to be the formula of Newton-Raphson method that we have derived in class. So say it equation number 1. Also, if epsilon n plus 1 is an error in the n plus 1 iteration, then xn plus 1 can be written as epsilon n plus 1 plus alpha, right? Similarly, you can write xn is equal to epsilon n plus alpha. So now in our formula, we can replace xn and xn plus 1. So when you replace over here, so this relation we get, and from here alpha to alpha will get cancelled. Okay, but now we can see that in denominator and numerator we have function. So Taylor series expansion we are going to use. So in general I have written, since f of x plus alpha is going to be this f alpha plus f prime alpha plus x square upon 2 factorial f prime f double prime alpha so on. But in denominator here we are having f prime epsilon n plus alpha. So what is going to be the Taylor series expansion for that? You are going to put an extra uh, prime here, extra differentiation is going to be here. So f prime x plus alpha is nothing but f prime alpha plus f double prime alpha plus x square upon 2 factorial f triple prime alpha so on. Right. Now using the following formulas in above equation, this expression we will get. This expression we are going to get, but from this expression I am going to ignore x, I am going to ignore epsilon n square term and the higher order of epsilon n square, right? And why I'm ignoring, why I'm neglecting, because they will become 0. Epsilon n is a very small error, and the time you will be having a higher order, so they are tending to 0. So we can always uh, do that. This paper is all about approximation, as we know. So this can be done, this can be neglected. So after neglecting epsilon n square or higher order, also we know that alpha is an exact root of our equation, so f alpha is going to be 0. So keeping this in mind, f alpha will become 0, and this term and further terms we are going to ignore. We are going to ignore, we are going to neglect them, and hence this expression we are getting. This expression we are getting now. Do further calculation, and this we are getting easily. Okay, this we are getting easily, but there is a typing error here. So what is the typing error? This must be epsilon n square f double prime alpha. This must be f double prime alpha upon f prime alpha plus epsilon n f double prime alpha. Now this is okay. Okay, so this is very easy. Only key point is here that you are having this extra f prime x plus alpha, and the Taylor series expansion will remain same. Only one extra prime derivative we have to use here. Okay, we have to use here, and now further we can see that, listen, now this expression, okay, I have to go back. So see, now here at the bottom in denominator I am going to take f prime alpha common, and the time you take in denominator f prime alpha common, you will get what? F prime alpha into 1 plus epsilon n into f double prime alpha upon f prime alpha. So from denominator I am taking common f prime alpha. Okay, and whatever you are having in denominator, when you will bring it in numerator, so it is going to be minus 1 power you will have here. Okay, so we can clearly see, you can easily verify this after taking denominator say common, this f prime alpha, you will get this expression. And now binomial expression, binomial formula you can apply over this, as we were doing in other methods also. So this will become 1 minus epsilon n f double prime alpha upon f prime alpha, and then plus, right? But listen students, now when you will multiply with this, so only when you will multiply with first, that term we are going to consider, and rest we are going to ignore, rest we are going to neglect here also. So then what do you get, that epsilon n plus 1 is uh, uh, almost same or approximate to epsilon n square f double prime alpha upon f prime alpha. This expression we get because we are neglecting the following terms. Okay, so epsilon n cube or higher order you are going to neglect here, so that will be better if you write this region here. So in this case, what do we get, epsilon n plus 1 is equal to m epsilon n square, where m is going to be f double prime alpha upon f prime alpha, and the time you will remove this sign of m, the time you will remove m, so proportional sign you will get, proportional sign you will get, or you can write as we were doing earlier, that epsilon n plus 1 less than equal to epsilon n square. So, or you can think that proportional sign will come in picture. And now what is the power of epsilon n, which is known as p in our case? 2. So rate of convergence of Newton-Raphson method is 2 quadratic, and this is the fastest one, as we already know.